Hi, in this video we're gonna show you how to work with Multisim. Multisim is a software that is used for simulation in electronics. So basically you create a schematic from your circuit, and then you can simulate your circuit and see the output, read the currents, read the voltage, and all sort of analysis before even you have to implement the circuit. In this way you can predict if there is any like an unforeseen problem, and you can go ahead and modify your circuit to finally reach your design target. Multisim has a lot of menus and shortcuts here, but we're going to just keep it limited to what we're going to use in the lab. Basically, I'm going to show you how to use these two shortcuts here and the simulate menu only to do the DC analysis as well as AC analysis. So in this way, what you do, let's start with the simple circuit. So let's start from the shortcut, the first shortcut. This is basically to provide you with the power source first. So we're going to do a DC analysis. So I'm going to choose the DC power here, and the symbol of a battery, which is a DC power symbol, is going to be shown here. I'm going to say OK. I'm going to drag and place it in here. Another thing that I need for every circuit is a ground. You can see the symbol of ground shown here. So I'm going to say OK, and I'm going to place it here on the blank schematic, and then that's enough for the voltages. So this is a 12-volt battery, but let's say if you needed a different one, I'm going to change it, for example, to 10 volt. So 10 volt, I change it here, and you say OK. So it's a very user-friendly to change the parameters even after you place them on the blank sheet. So next part is the components. So the next shortcut is place basic. If I click on it, all sort of components are shown here: resistor, capacitor, inductors, relays, transformers. So I'm going to just place just two resistors here. So I'm going to click on the resistor here, and the default is 1K, and you have the symbol of resistor here. So if I say OK, it's going to give me a resistor, and I'm going to just drag and put it here on the screen, on the sheet. And then again, the wizard is going to pop up automatically because it's expecting you to choose more component. I'm going to choose again another resistor, so I'm going to say OK. And let's say if I want to change the direction of this to be a vertical direction, Control R. So Control R means that it's rotate. So R stands for rotation. So it rotates the resistor symbol, and I can place it here. And let's say that's enough for me, and I place escape so it goes away. Let's say if I wanted to change the R2 to another value, I can just double check here, and then let's say 2K. I'm going to say 2K and say OK. And you see the value of the resistor was changed to 2K. Now it's the time to connect them together. So in order to connect them together, move your mouse on the component, on the one end of the component, and when you see the cursor becomes cross, it means that it's ready to do the wiring, and just you drag it to the other end, and then you click and it's connected. Again, move the mouse in this ending, and then press and drag it, and then it's connected. Again here, connected, one ending, connect to the other. Now everything is connected. Let's say I want to measure the voltage here, simulate the voltage across resistor 2. Here the place that I have to choose the simulate menu. I press on the simulate, and I go to the instrument, and I need a multimeter. So I'm going to click on the multimeter. So I'm going to place the multimeter here. Now I have to connect the multimeter to this point. So because I'm measuring the voltage across resistor R2, and this is going to show me the like the voltage. If I run the simulation here by clicking on this run button and then double clicking on here, it's going to give me 6.66 volt. It means that the voltage across the 2K resistor with a 10 volt power supply is going to be 6.6 volt. Let's say if I wanted to also measure the current, in order to measure the current, I have to put the current meter in series. So I have to cut the wire from here. So I'm going to click the wire and delete it. So first I have to stop the simulation and then delete the wire. And then I have to go to simulate again, instrument, multimeter. So I'm grabbing another multimeter and I'm going to connect this multimeter in series. Again, I'm doing this because the current meter has to be in series here. So all I have to do, click here and click on amp to show the current, and then if I run the simulation, so 6.6 volt is what I was getting before for the voltage, and 3.3 milliamp is the current that passing through this multimeter going through R1 and R2. So this is all we need for a DC analysis in our experiments. And now I'm going to show you how to do the AC analysis. So I'm going to close this. I'm going to stop the simulation. I don't need the multimeter, so I'm going to get rid of the multimeter. And let's say I'm going to get rid of one resistor, and I want to put another capacitor for AC analysis. So I'm clicking on place basic. I click on capacitors, and the default is 1 microfarad. Let's stick to the default and Control R to rotate it. And I'm going to put it here, and then that's enough for me. I'm going to connect them together. So here, here, here. And then I want to monitor the output voltage across the capacitor and like input voltage. For this one, sorry, I had to get rid of the battery because we are doing the AC analysis. So I have to get the AC power. Okay, I'm going to get the AC power here, and that's it. Now I'm going to connect the AC power here. And if I double click on this, it's 120 volt. Let's say I want to stick to 10 volt, and the frequency is 60 hertz. Let's say if I want 100 hertz, so I can change the parameters here and then say, okay, everything will change here. Now I need to go to the simulate instrument, and I need an oscilloscope. So I'm going to grab an oscilloscope and put the oscilloscope here on the sheet and on the schematic. So channel A and channel B. I'm going to connect the channel A to the input, which is this part. I'm going to connect channel B to the output, which is this part. And the grounds are going to be connected together. So the minus is going to be connected to the ground. So oscilloscope is connected. All I need is just to run it and double click on oscilloscope. And you can see the simulation of input and output is like visible on the screen. Channel A, these are the parameters. Let's say I want to change the channel A to higher voltage. So you see the scale for channel A was changed. The scale for time division, I can change it to make it more compact, or I can open it so it's like less compact. And every time I want to, let's say, capture, I can just simply press on the pause, and the signal is going to be paused. By clicking back on play, it's going to be played again. So this is the way that you monitor the AC signals. Another thing that you need to know is AC analysis. So if you click on the simulate menu, go to analysis and AC analysis, this wizard is going to pop up. This actually is telling you that the body plot or the AC analysis for magnitude and phase is going to start from 1 hertz and going all the way to 10 gigahertz. So you can change this one. depend on how wide you want the frequency response to be covered. There is output tab here, so I have already chosen the current in capacitor. I can just remove it again, show you how I did it. When it comes up for the first time, everything is blank here, and you have all sort of power, voltage, and current parameters. So I'm going to choose the first one, which is current through capacitor 1. I'm going to say add. So this is going to do AC analysis and the frequency response for the current going through the capacitor. If I click on the simulate, it's going to show me two graphs. One graph is the magnitude versus frequency. The other one is phase versus frequency. So you can see that for the low frequency, the current is low, and as the frequency is increasing, the current is going to increase, and the phase is going to change from 100 degree to minus 10 degree as the frequency starts from 1 hertz and goes up to 10 gigahertz. This is AC analysis, or body plot is another name for this sort of analysis, and that's what you need for a few experiments to perform. I think that's about it for the multi-set training. I hope you liked it, and thank you very much for watching it.
The power supply we are using in this experiment is an Agilent power supply. It's got a terminal for 6 volt, a terminal for 25 volt, and a terminal for minus 25 volt. Please notice that the green terminal, which is shown and labeled by a ground symbol, is not going to be used. This is connected to chassis and we are not going to use it. So first we turn on the power supply, and the output is off, so we just push on the output on button to turn it on. The voltage is shown on the left side, the current drain from the power supply is shown on the right side. So let's say I have connected a cable to the plus minus 6 volt terminal, and I want to program the 6 volt terminal to get like a 2 volt or 1 volt. So first I have to press on plus 6 volt button, and you can see the plus 6 volt is shown on the display, and then I have to rotate this button until I get 2 volts on it. So 1.34567, and this is 2 volt that I'm getting from these two cables here. And for, let's say I want to get minus 15 or minus 5, so what I do, I connect this to the common, and I connect this to the minus 25, and then I have to press on the minus 25 button. This is minus 25 button, and you can see again on the display minus 25 is shown. Then I have to change the current knob again all the way to get minus 15. So right now I'm getting minus 15 from these two cables. And this is the way that this power supply is working. There are other buttons here which are basically for storage, for I/O configuration, or recalling the configuration, which we're not going to use in this experiment. In this lab we are using a digital multimeter from Agilent. As you can see, there are different buttons here that if you press each button, one function is going to be implemented. The first one is DC voltage, so if you want to measure DC voltage or AC voltage, if you want to measure a resistor here, if you want to measure frequency, and there are other factors that for this experiment we're not going to use. And there are also the parameters that could be measured and labeled in blue on the top. So the first one is DC current, AC current on the top, and the resistor for high wattage resistor, or you want to measure the period. For this one we need to press shift and then this one. So let's turn on the module to see how we can measure something. For example, let's say if we want to measure a DC voltage, right now it's on millivolt DC. It means that it's going to measure the voltage, and the cables that are connected to the point that we are going to measure the voltage at are supposed to be, one of the black one is always going to the middle, labeled as LO, it's the common and is the ground cable, and the other one is connected to here because this terminal is to measure the volt, resistor and diode. If you want to measure other thing, for example, if you want to measure the current, you have to go to this one. So you see this one is labeled as I. It means that you have to remove this one and connect it here to the lower one to measure the current. In this case, you have to press the shift button and then press this one, and you can see that it's shown on the display. It's showing milliamp DC. It means that DC current is going to be measured at this point. If you want to measure the resistor, a high wattage resistor or a low wattage resistor, for low wattage resistor, again, you keep this one here, and then you simply change this, and then you push on and you see that it's the display is showing the mega ohm. It means that it's trying to measure the resistor. So if you connect the resistor to the other two sides of these cables, then the equivalent resistor is going to be shown here. So this is our digital multimeter. You can measure the frequency or period, but normally for those parameters we prefer to use oscilloscope. So for this one we measure the current and voltage, and resistor are the values that we are going to measure. One of the problem that I have seen a student, one of the mistakes that common mistake is that this button, front rear, this has to be all the way up. It means that anything which is connected to the front terminals are going to be measured. If you press this one, it's switched to rear, and you can see it's shown like here, it's shown at rear. It means that anything, there are some terminals in the back of this module, and we never are going to connect anything to the back, so make sure it's always pushed up and it's not pressed. So a wrong measurement is not read by the multimeter. Another thing, that if multimeter is not changing as you change the voltage or value, it means maybe the multimeter has a burned fuse. So there is a fuse that needs to be changed, and that fuse is normally changed by the instructor, lab instructor. So make sure that you mention to the lab instructor that your multimeter value are not changing. So it means that we have to come and and change the fuse and fix it for you. In next part, I'm going to show you how to use breadboard to connect electronic components together. So breadboard is a device that has a lot of holes here. As you can see, there are a lot of holes in like everywhere on the breadboard, and they are connected based on this diagram. So if you look at the diagram, you see that there are two rows on the top. So I'm going to just label the rows on top, this row, and two rows on the bottom. So this row and this row. These rows are connected together. Of course, you see a big gap here. Basically, this gap is telling you that there is a cut here, meaning that the row on the right is not connected to the row on the right, but for this specific breadboard on the top, the whole row is connected. So basically, this row, every hole on this row or on the line that I am marking it by red color, it's connected. So let's say if I connect a resistor, one pin of resistor here and another pin of resistor in here, then it means that I have connected
this resistor in this way. It means that the resistors are connected from one end. So the same for the other one. This row, all holes are connected. So it means that, let's say if I connect one resistor in this hole and one in this hole, and then another resistor I connected here and connected to this. These two ends are connected together. It means that I have resistors connected from this end together, and these pins are connected together again. It means that these two resistors are connected from both ends, meaning that these two resistors R1, let's say, and R2 are in parallel, because the resistors in parallel means that both pins are connected together. And if you look at the middle rows, first of all, you see a big gap here, meaning that this gap is breaking the breadboard in two similar halves, and nothing from top side is connected to anything to the lower side. So no hole from this top side is connected to any hole to the lower side. But the holes in the middle are connected in a column. So it means that this hole is connected together. This hole is connected together. All holes in this column connected together. Same as the lower part. All holes in this line are connected together. All holes in this line are connected together. So if I put a resistor like this, I connect to this hole. And then if I connect another resistor like this, basically it means that this, because this column is connected and all holes in this column are connected, so I'm going to mark the columns by arrows. This means that I have connected these two resistors like this. Again, it means that these two resistors are in parallel. I'm going to show you an example of putting two resistors in series. So if I put a resistor here and then a resistor here, because these two resistors are connected in this line, it means that the resistors are like this. It means that they are in series.
So let's say I want to measure the current I3. The current I3 is the current passing through R4. So what I do, I have to use a multimeter cable, which is simply this cable. So I connect one side to volt. So this is my volt connection. I connect the other one to the common connection. So this is my common connection. And then what I have to do is to connect the other side of the cable, which is these two sides, in series with the resistors. So how would I do that? So what I do, I disconnect these 2 points from each other, and then I put like a current meter in the middle, and a meter in here. So this is the way that I have to do. So a disconnection first, and then an insertion of a current meter in the middle. So how we implemented on the circuit is, so to disconnect this point from this point, I have to remove R4. So one side of R4 is disconnected, and now these two are the two disconnected points. And then is the insertion part that the current meter has to go between these two. So the cable from the meter goes between these two. I recommend that you always secure a point, not to leave any point like in the air. This point is already in the air. So the professional way is just to connect it somewhere on the breadboard, let's say here, and you got to make sure this point is not connected to anywhere, and then simply connect these two together. Now the current is going through the multimeter, and I can measure the current at R4. So always make sure that you connect the current meter in series. There are two steps: disconnection, so 2 points have to be disconnected, and then the insertion, which is the insertion of the cables from the multimeter right at the points that you disconnected. If you want to measure voltages, it's really easy. You don't have to disconnect any points from each other. You only connect. For example, in order to measure the voltage across R4, which is this resistor, I simply connect the multimeter in parallel with the resistor. So you can see that simply these two cables are measuring the voltage across the resistor. So to measure the voltage, you simply connect in parallel to the component. No disconnection is needed, as opposite to the current meter or measuring the current. So hope this video helped you to better implement the circuits. If you have any question, feel free just to send me an email, and I would be happy to answer your questions. Thanks for watching the video, and have a good day.